Good afternoon, everyone. Thank you for participating to the third online training. This time, the training topic is about fluid measurement. Fluid measurement requires not only capture image by a high-speed camera, but also requires to analyze from the images. This time, we invite guests from Seika Digital Image. Seika Digital Image is a well-known company as PIV system integrator. We asked them to share their knowledge and know-how about fluid measurement. There are 3 presenters today, so please introduce yourself from Ko.
Good afternoon. My name is KoncertoII from nack Image Technology. I'm in charge of the Asia market with Jun. Today, I'd like to share with you the detail of the fluid measurement.
Hello everyone, my name is Kota Nagatomi. I'm from Seika Digital Image. I'm a sales representative of Seika Digital Image. I hope you guys will get interested in today's seminar. So, I will give you introduce about the PIV later. Thank you.
Hello, my name is Jun from sales group of Seika Digital Image, and I'd be glad to have the opportunity to present our company's product with NAC. And actually, there are 2 names Jun here, so please call me Seika and Jun. Thank you.
Okay, so could you please introduce your company, the Nagatomi-san?
Okay, let's start with what the Seika Digital Image is. I think some of you guys already know what the Seika Digital Image is, but most of you guys don't know much about us. So I'd like to introduce our company first. Seika Digital Image is one of the group company of the Mitsubishi Corporation. We independent from the parents company called Seika Corporation about 9 years ago. We have about 30 members, also have a technical engineering team. We mainly sell many measurement systems based on the laser and imaging technologies. We are not only system engineering company, but also software and third parts maker. So we often collaborate with NAC. We are well known as a PIV pioneer in the Japanese market, more than 25 years. PIV and the practical image analyzing is good match with the high-speed cameras. If you add these softwares and the optical items with the NAC's cameras, you will be able to propose new ideas to the customers. Thank you.
Thank you very much for the company introduction. Okay, in this training, we will explain about particle diameter measurement and PIV. And NAC presentation mainly explains about visualization. And then the Seika presentation explains about image analysis and details of the system. Okay, so let's start the training. Please start the presentation from Ko.
Let's move on to the first topic, particle diameter measurement. In the fluid measurement, there are several kinds of range to analyze as airflow, water flow, and spray, and droplet so on. And there are many measurement methods. Image analysis technology with a NAC high-speed camera is enabled to analyze the fluid measurement optimally as airflow and water flow and spray so on. These phenomena is usually difficult to shoot with ordinary camera. About the range of the analysis with image data, there are several kinds of the items like vector, fluid speed, and particle diameter, and distribution, so on. When you propose fluid measurement to your customer, it's required to propose the appropriate measurement and shooting method according to the customer's need. From now, I will share with you the example of analysis. In the fluid measurement, there are several kinds of the phenomena to analyze, as airflow, and water flow, and bubble, and spray, and ultrasonic flow, and shockwave, so on. And there are several kinds of output, like this. Regarding the shooting method, it's required to select the appropriate shooting method according to the target phenomena. Today, I will introduce the two methods which is commonly used because it's difficult to explain the all shooting method and process according to the phenomena in only one meeting. First one is a particle diameter measurement. I will introduce the shooting method and software to analyze the particle diameter and distribution. Second one is a PIV analysis. There is a method called as a PIV, particle image velocimetry, to analyze the vector of the airflow and water flow. I will share with you the measurement method and system and software about PIV. There are several kinds of approach to fluid measurement. At first, I will focus on the particle diameter method to explain in detail. About the Shuriren and LIF, we will arrange another training to introduce these topics another time. About spray and particle diameter measurement, there is a light sheet method and shooting method as a backlighting and front lighting. When illuminating with a light sheet, we can analyze the flow of specific plane. It's common to use the light sheet in fluid measurement. This image is an example to shoot the spray with ACS1 in front lighting. This is an image to shoot the diesel injection with ACS1 in backlighting. About measurement of the injector spray, there are some requests to analyze the distribution of spray and penetration, which means to analyze the distance spray reached. This is an example of the droplet. About droplet, we had some requests to analyze the contact angle when particle touched, in addition to the analyze the particle diameter. When you shoot the droplet, you need to magnify to capture each particle. ACS has advantage in shooting droplet because ACS has a higher resolution and frame rate. This is an image to shoot the spray atomization emitting from the nozzle with backlighting. It's common to shoot with backlighting when analyzing the particle diameter. The fundamental research about spray and droplet is usually used for development of rocket engine and engine combustion. It's necessary to shoot with high frame rate because it required magnified shooting. ACS has advantage in this application because it has high resolution to shoot with high frame rate. In fluid measurement, it's common to shoot at high frame rate from the 1000 frame per sec to the 100,000 frame per sec. like this range. ACS has a higher resolution at 1 megapixel at 54,000 frames per second. So you can analyze the flow measurement with good accuracy. When analyzing the particle diameter, it's required to arrange the camera and light source as laser and LED and appropriate lens so on. Magnified shooting is necessary because the particle diameter of the target object is very small, and this diameter is from about 10 micro to 100 micrometer. So that it's most important to select the appropriate lens, considering the resolution of camera and field of view to shoot with camera. Please select appropriate lens, considering the spatial resolution and magnification. And it's required to arrange the other equipment like tripod and microstage and software to analyze the data. About laser light source for high-speed camera, there are mainly two types of laser, continuous CW laser and high repetition pulse laser. About high repetition pulse laser, you need to synchronize with the pulse of laser and shutter of high-speed camera. Recently, some customers sometimes select to use LED light source, considering the safety. About software, some software has a function to analyze the spray angle, and concentration. After that, Seika will make a presentation about these topics. We shoot the spray and bubble in water with NAC high-speed camera and analyze the particle diameter. From now, I will introduce this process with insert video. Please check the process of the particle diameter measurement. At this time, we selected appropriate lens, considering the spatial resolution and magnification. Please check this point in this insert video. From now, Seika will introduce the detail about software Dia Image. 町井さんお願いいたします。
Okay, I will explain again, and I would like to start the introduce about the particle image analysis by shadow graph measurement, and also how to take the image of shadow graph more details. So the purpose of this section is to outline the shadow graph measurement methods, making use of NAC high-speed camera system, and system configuration examples, and introducing about our particle analysis software, Dia Image, so named Dia Images. So my talk is divided into 5 parts, so let's start with slides. So to start with, I will describe how to take a shadow graph image first. So as shown in the figure below, it is necessary to face the camera and the light source in order to obtain a clear shadow graph image. Then make the light source as uniform as possible, and separate the background from the particles. At this time, if the brightness difference from the background is small, the analysis will be affected. Here is kind of the images. So if you want accurate particle size measurement, you need to high-speed shooting so that the subject does not blur. So here's the captured images, as Kikuchi-san explained before. Yes. So next, I will explain the keyword in the shadow graph measurement method. And a lens magnification. So lens magnification is use the lens and a teleconverter according to the shooting target. And a second, and a working distance. The working distance refers to the distance from the tip of the lens to the subject. So how far you can get from the subject is important in shooting. And next, spatial resolutions. So spatial resolution depends on the resolution of the camera. So you need to calculate the optimal resolution from the particle size so you want to take in images. And finally, exposure time. The exposure time is the shutter speed of the camera and the light emission time of the light source. So in shadow graph photography, it is often the case that the small area is measured. So in that case, as the camera magnification increases, the flow velocity of the subject to be photographed becomes relatively faster. So you may need a faster speed than the normal exposure time. And I will explain a little about the spatial resolutions. For example, so here's the example case 1 and 2. And assume that the shooting angle of view is 1 millimeter. So if the resolution of the camera is about 1,000 pixels each, the size per pixel is about 1 micrometer. So this is the calculation of spatial resolution. So in order to measure the particle size accurately, it is necessary to calculate the spatial resolution accurately as well. So next, I will give a supplementary explanation of the exposure time. In order to measure the accurate particle size, it is necessary that the capture image is clear. So if the captured particle get kind of picture blur, it will be difficult to accurately measure the size of the particles. So let me show you the sample pictures. Here is the kind of the image the picture blurs means. So this photo is in kind of the image of the fountain. So as you can see, the particle size cannot be measured at long exposure time because the water in the fountain does not stand still. So therefore, we will shoot the particle accurately by increasing the exposure amount and a shutter speed, like this. So this photo. So you can see kind of the particles, and then yeah. Sorry. So next, I will introduce the component making use for shadow graph images. So we recommend using a high-speed camera for objects with high flow velocities. For example, when measuring particle from spray nozzles, injectors, and inkjet nozzle, so on. So you better to choose a high-speed camera one, like ACS series and HX series is better to use to take the images. So. And the high sensitivity camera type can handle the phenomenon of relatively slow flow velocity, such as micro bubble or like that. And next, I will explain the light source selection. So there are two types of light source we handled. So lasers and LEDs. Our LED light source can be used not only in continuous light but also in pulse mode, so that you can use kind of the PIV mode as well. The differences between a laser and the LED is that is kind of the recommended to use a laser light source, especially when measuring high flow velocity or a small area. So reason is that the laser light source has a much faster flash speed than the LED light source. So this is because it is possible to accurately measure the phenomenon of high flow velocities. So the LED light source can shoot with a maximum flash time of about 0.2 microsecond, while the laser light source can shoot with a flash time of up to about 15 nanoseconds. So it's very, very high faster than the LED light source. So you can, it's more, how to say, sorry, I cannot say how to say.
What? Efficient.
Efficiency, yes. Sorry. And here is a reference example. So if you set the shooting angle of view is how to take the clear image of shadow graphs. So if you set the shooting angle of view is 100 millimeters, the flow velocity is 1 meters, and the ACS series is used of this situation. The required frame rate is about 10,000 frames. So if you like to measure more small area and a high speed velocities, so the shooting angle of view is, for example, the 10 millimeters. The flow velocity is 100 meters, and the ACS series is selected for the camera as well. The required frame rate is over 1 million frames. So if you need to shoot very fast flow velocities and small areas, so you need to make use of a laser light source. Okay, now and for reference, we would like to introduce the LED lighting that we handle. So this is very high brightness, multifunctional LED light source. Here's the made in Poland things, and it also has a pulse mode function, so that it can be used for PIV measurement as well. And the light seat optics can also be purchased as an option, so you can use the PIV mode. And also there are various lineups of wavelengths such as green, blue, and UV is available. So now please take a look at brief video introductions. I will show you. Here's a light source, and it is very compact and high efficiency. And you can, here's the kind of the continuous mode. You can use also pulse mode as well, and PC control level. Here's kind of the images. Yes. Okay, now next I will show you our measurement example of the shadow graph measurement method. And as for our sales result first, we have a lot of sales results, including domestic car manufacturers, material-related manufacturers, and heavy industries companies, universities, and National Research Institute, so on. So we did custom order the system according to the customer's request and use it in various fields. So now I would like to introduce some of them, the examples. So the first is an example of visualizing droplet from an inkjet nozzle. So as you can see in the images, the droplet eject from the inkjet nozzle have a phenomenon in which small particles are separated from large particles at the same time as they fall. Yeah, here's the images. Yeah, and we have built a system for the customer's purpose of visualizing this kind of behavior of these small particles. So the light source is a laser because it is very fast phenomenon and so small areas. So also the frame rate of the camera is about 10 frame rate, 10 FPS. So the exposure time of the laser and a camera is adjusted according to the timing when the phenomenon occurs. Like this. Okay, next we will introduce an example of a two-fluid nozzle. In this experiment, the images were taken just below the two fluid nozzles and 1 mm and 2 mm below the nozzle. The purpose of this experiment is to visualize the phenomenon of fine particles coming out of the nozzles. So here's the image just below the nozzle. So as you look going down from the nozzle, you can see that the particles are gradually separated. But as the image of this slide, it cannot be seen as a kind of particles because it is not atomizations. So this experiment means kind of pictures of progress of atomizations. So here's 1 mm below from the nozzles. So here's the 2 mm below from the nozzles. So you can see kind of the particles. So maybe it could analyze the particle image size. The next is this is a photograph of microbubbles. The image is the same as the PIV measurement example introduced by Mr. Kikuchi earlier. Here's. And this is an example measured with our particle size analysis software. So I will introduce about software in the following sections. Here's kind of the images. So yeah. Okay, finally, I would like to introduce an example of measuring a very fast phenomenon. So this is an image of breakdown that occurred when the pulsed laser was fired into the water. So bubbles occurred when the laser reached the water. So, and you can see that a shock wave is generated around the bubble. Here's kind of the shock waves. So by using a pulsed laser, as in these examples, so it is possible to clearly capture a very high-speed phenomenon in a small area. So the expected speed is about 2,000 meters per second. Sorry. It's very small areas. So. Okay, now I'd like to introduce our particle analysis software. So our particle size analysis software can support various particle size measurement. It can be used for various purposes, such as an analysis of droplet from inkjet nozzles introduced earlier, and spray nozzles, and microbubbles, and kind of powders, and shape determination of semiconductor materials, and so on. So please have a look at the video that introduced the analysis case. Okay. First, load the captured image into the software. Yes. So next, calibrate to determine the size from the captured image. So in order to measure the accurate particle size, so it is necessary to set the size of 1 pixels. So take an image with the scale like this, and at the angle of view where the particle were measured, and load the data into the software. After setting the size, the software will calibrate automatically. You can put the actual size in here. After that, the software can automatically select it in the actual size. So the next, set the area you want to measure. You can easily specify by using using a function, a kind of called LOI. Sorry, so the video is kind of faster. So imaging process. The next is imaging process. So you will set the criteria for determining the particle size. The software determine the optimal threshold for recognize the particles. Yeah. And also at this time, non-particles are excluded by the threshold value, such as size, like this, and various conditions such as circularity and brightness, and it can be set for the threshold value as well. Okay, after the image processing, you can generate the measurement result by report. So the report format can be generated in Microsoft Excel format and a text format. So as for the analysis results, various results can be generated, such as minimum particle size, maximum particle size, and average values can be reported, and kind of amount is as well. So here is the software. The procedure for the analysis. So, okay, this is my explanation. So it was kind of so quick, my explanation, but that is an overview of shadow graph measurement method, components, and the software introductions. So before wrapping up my explanation, so let's sum up the important points in particle size measurement with the shadow graph method again. So summarize. So one is for the shadow graph measurement method, so it is necessary to select the required system according to the imaging areas and a flow velocity and a particle size and a particle density. So if you have any question and inquiries, so please feel free to contact us for details at any times. And two, tips of shadow graph measurement method. So the background should be bright and have a uniform brightness distribution. And that image showing the difference in contrast between particles and the background. This is kind of the tip of shadow graph measurement method. So, And finally, Dia Image is specialized in particle size analysis. So if you have some sample image or something, so we can also perform kind of test analysis. So please contact me at any time. Okay, thank you so much for your attention. Okay, if you have any questions, we'll be happy to answer them via chat. Okay, yeah. Thank you.
Okay, thank you very much for the presentation, Machi-san and Cole. Okay, then we're gonna go for the PIV presentation. So you can start the presentation, Cole.
Let's move on to the next topic, PIV. I will introduce the PIV analysis. PIV, particle image velocimetry, is a common method to analyze airflow and water flow and vector. As a second method in today's meeting, I will introduce the method of PIV and PIV analysis software, Seika KoncertoII. About PIV, you need to put tracer particle into water flow and airflow, and set the data sheet irradiated in the form of slit, like this. After that, you can analyze the direction and velocity of particle flow through the capturing some shining particle on slit. This is the image. This image is example to shoot airflow of the air conditioner. We set the laser in front of the air conditioner and use the smoke as tracer particle. PIV analysis result is the light image. Vector shows the direction of flow. Blue shows the low speed flow, and red shows the high speed flow. This is the system configuration for the PIV. High-speed camera is usually used for the time series order analysis. It's common to use a laser light source to capture flow with slit light. Our laser light source, their pulse laser and continuous CW laser. You need to select appropriate light source according to the velocity you want to analyze and the customer's budget size. Laser light source is required to handle with care for the safety reason. So there are some cases LED light source is used as sheet light. And you cannot create a slit light with only laser light source. So you need to arrange a laser sheet optical system to transform to sheet light. You need to arrange appropriate appropriate laser sheet optical system according to the irritation area and required sticks. And you need to arrange the appropriate lens according to the field of view and working distance. Selecting the appropriate tracer particle is very important. When we analyze the airflow, oil mist and smoke and dry ice is used as a tracer particle. When we analyze water flow, and we use tracer particle which is closing to water, including the specific gravity in water. When you use a pulse laser, timing controller is required to synchronize with camera, and you need to arrange tripod or camera frame, a microstage, and PIV analysis software. Seika DI will give you the detail of PIV software KoncertoII and know-how when you shoot with camera. This is a general system configuration for PIV. This is an offline system shooting with camera and lens and laser and operation software. Finally, putting the data into PIV analysis software. This configuration is low-cost solution as PIV system. At this time, we made an insert video about PIV using the CW laser and LED light source. I will introduce this video after that. This is a high-end system configuration for PIV. This system is enabled to synchronize with the old system as camera, a timing controller, and high-repetition pulse laser. PIV analysis software, Concerto, can control all systems at once as laser and camera. Concerto can control the Highspeedcamera with double pulse laser and frame slowing function of the camera, like this. We can shoot with a shorter interval of PIV while keeping resolution. I will introduce an insert video about high-end system with high-repetition pulse laser after that. This is an example about 3D PIV analysis. With one high-speed camera, you can analyze 2D PIV as two axes, X and Y. With two high-speed cameras, you can upgrade to analyze 3D PIV as three axes, X and Y and Z, within the sheet plane. From now, I will share with you the insert video about PIV. From now, Seika DI will give you the more detail of PIV. お願いいたします。
Okay, hello everyone. My name is Kota Nagatomi, sales representative of the Seika Digital Image. Today I will introduce about the PIV system. Today's seminar we focus on to understanding the basic idea of the PIV. We will introduce more technical contents, equipment, and algorithm next time. So here's a breakdown of the today's seminar. First, outline explanation on PIV. The second is the applications. The third, variations of the PIV. Fourth, how to choose a camera, light source, and tracer. Fifth, PIV equipment. Sixth, shooting procedure with the CW laser. 7. Introduction of the PIV software. 8. Variation of other PIV. And the last one is a Q&A. So let's start with what is PIV. A PIV is the initial letter of the particle image velocimetry. Like here, particle image velocimetry called PIV, which is well known as a measure aerodynamic and the hydrodynamic velocity measurement method, developed in the late 1970s. PIV is a method of a visual measurement for calculating flow, split tracer particle in the flow. The motion of the particle follows the actual flow by using high-speed, high-sensitivity cameras to take the image of the particle, which means flow. Then analyze the image with PIV software for understanding the flow velocity and directions. For PIV measurement, laser light sheet is used for light source. So now, why laser light sheet is used for PIV and green color? The laser is made into a light sheet in order to visualize only the space where the laser sheet hits. Light sheet makes to understand the flow of the specific space on the plane. It is also called a cross-section. If you take a look at the sketch of here, we can measure only the area where the light sheet hits. Here is a laser and light sheet comes from here to here. If you use a normal light source, depth information is also visualized. So it's not good for quantification and calculation. Oops, sorry. For the PIV measurement, while worldwide green color laser is used, there are several reasons: cost efficient, high power, and good match with the sensor. First of all, for understanding PIV, we should think about the visualization. In our daily life, airflow is not able to see it. So for visualizing airflow, if you spread the smoke in the airflow, you can visualize invisible airflow like this. Here is air cleaner. Normally, you cannot see anything. But if you put the smoke into the air cleaner, you will see how the flow is moving. So now, what is the difference between visualization and the PIV? See the picture and here. By using a visualization techniques, the airflow can be visualized, but just by visualizing the flow velocity cannot be figured out. Velocity cannot be figured out. So now by doing PIV analysis, direction and the speed of the flow are able to get vector information. So now let's review the basic idea of PIV. PIV is the first letter of the particle image velocimetry. Please remember that. So how to measure velocity and angle? The velocity vector is calculated by the acquiring two consecutive number of particles. It's a key point. For analyzing the number of the particle in the same area of the image, we call interrogation window. This is a basic idea of the PIV. From the first captured image to the second image, how much pixel the number of particle moves. To compare first and the second image, then calculate the correlation from first and the second, we will see flow speed and the direction. Please also note that the PIV is not a particle tracking. We don't see the individual particles. It's a PTV. PIV see number of the particle movement. So here is an application of the PIV. PIV can be used for measuring any kind of force. For example, airflow around the car, airplanes, and also buildings. Explosion inside of the engine. Indoor airflow, water flow, water pump, welding, spray, and also combustion. Sinks experiment. So here, PIV has a lot of variations as well. The 2D PIV, this is the most common PIV system in the world. Here, 2D 3C PIV, we also call stereo. Here is a high-speed PIV, but the high-speed PIV, I just categorize this, but the high-speed camera can be used any type of PIV. For example, high-speed camera can be used with a 2D 3C, shadow graph. So and also micro PIV, if you want to see a micro scale, you can also do the PIV. So today, let's focus on the 2D PIV because very simple. On the 2D PIV, we can categorize in two systems according to the laser source. The first one is a CW laser. CW means a continuous wave. And second one is a double pulse laser. The CW laser with a 2D PIV usually use a high-speed camera, CW laser or CW LED, laser seat optics, particle generator, timing controller. This is only for the real-time analysis. And computer and the KoncertoII. KoncertoII is our own software for the PIV analysis. If you compare CW laser and the double pulse laser, CW laser is a cost efficient and simple, versus double pulse laser has a high performance. But if you use a double pulse laser, you have to think about the delta T and frame straddling. It's a little bit complicated compared with the CW laser. So I would like to introduce the double pulse laser the next seminar. Okay, next one is a selection of the equipment and conditions. First of all, we must think about the measurement environment. Measurement environment is in air or liquid, so we can decide the seeding type. Next one, flow velocity, high speed or low speed. We can decide the type of light source, image size of a frame rate, phenomenon, steady flow or turbulent flow. We will also decide the type of cameras, time of resolutions. These ideas are all the same for the other PIV as well. But today we focus on the 2D PIV and the CW laser. So next one, how to choose a camera. Time resolution and the camera resolution, I mean the sensor resolution and sensitivity. It depends on the application. So if your potential customer is interested in to use a PIV system, you have to ask several questions. And here, ACS1, HX7, and MCOM, these cameras, online application is available. Online application, this is one of the keywords today. With KoncertoII PIV software called KoncertoII, this KoncertoII has a function to control the G3 cameras. I'm going to explain about the online means later. But if you have an online function, it's very useful compared with the other camera makers. So I will explain it later. And also this is an introduction of the camera selection. So for example, measurement area is 30 centimeter by 30 centimeter. ACS1, you will see follow-up speed is like this, FPS like this. So it's a kind of like a diagram. You can compare customers' requirements, which camera is better to use. So okay, next one. In the analysis window, with a higher resolution, more analysis window can be set in the image. And it is possible to graph the details of flow. If the resolution is low, even if you shoot the same area, you can only graph the general flow. So I recommend you to use a high resolution. Okay, next one, let's talk about the light source. For the PIV measurement, laser and LED are widely used. But it is a pros and cons. Here, this is a laser light seat, and the right side, it's a LED light seat. If you compare the left side picture and right side picture, the left side, you will see flow movement more clearly. So if you choose a laser has a high power, wide variety, and also many option parts. And also this is very important. If you use a laser seat can be very thin. If the laser light seat is very thin, measurement quality is high. But compared with laser, LED is a safety and cost efficient. But compared with laser, light seat is not so thin. So if you use a LED, measurement accuracy is not so high compared with laser. So we decide the camera and light source. Next one is the seating. So if you compare two pictures, smoke for the visualization, flow where you want to follow the movement. But if you use all seating can be spread uniform density. So it's more good for PIV analysis. Okay, next one, the equipment. For the PIV measurement, of course you need to choose a camera and lenses. And timing controller. Timing controller is necessary to use for the online. The third, light source. I introduced the CW laser today. CW laser has lots of varieties. High power double pulse laser, high repetition double pulse lasers, and also available to use. And also, as June introduced you guys, we have a high brightness LED series as well. So we can make the light into the light seat as well. And here is a light seat optics. We also have a own products of the light seat optics, because for PIV measurement, camera, tracer, laser, and also necessary to use a light seat optics. So we make this kind of items by ourselves. The next one is a seating generator. This one called CDS 1000. The Japanese major car company, Honda and Seika, collaborated to make this seating generator. This is the best item to spread oil mist evenly and widely. So I strongly recommend you to use this seating for the PIV measurement. And also there are the several seating generators by using oil mist. This is a smoke generator. It's good for visualizing. Can be used for the PIV measurement. And also, if we think about the seating generator, we also need to think about the material. The smoke, like a smoke generator, we use a propylene glycol, oil mist called DOS. This is good for the PIV. And next one is a solid particle. Solid particle is this one. This is a very good for the combustion flow. And for the water flow, micro bubble generators, we also have this. And 6, this is a particles for water flow. Particles also has lots of different types. For example, silicon dioxide, and also nylon particle, and this one is a fluorescent particle. So we choose these particles depends on the application. If you measure spray and powder, these materials themselves are already particles. So sometimes you don't need to use a seating generators or this kind of particle. Spray themselves are already particle. Next one is a PIV procedure. The first, of course, you need to shooting. Experimental environment preparation is a long word. So the first setup camera, adjustment of laser, light seat, and tracer. The next one is a calibration, the new word, calibration. The third, shooting particle image for the PIV. The second chapter is for analysis. The first, you have to confirm you took the picture is good for the PIV. So if you need to check a brightness, balance, focus, particle displacement is good by preprocessing. Then do the PIV analysis, correlation, and processing. So here is another key point. Control and analysis PIV software called KoncertoII. KoncertoII has a real-time analysis function. I often call this function is online, that allows shootings and analysis at the same time. It is possible to simplify to work time and significantly reduce the work time. Oh, I say the same. So, and next, procedure for the CW laser. First, seeding particle. Here's the image. Flow comes here to here. You have to think about this is like a wind tunnel. Flow comes left side to right side. And tracer called seeding. You have to follow in the flow, so we do the seeding from here. And here is a light laser. So we have to use a laser light seed like this. And here is a camera. The second procedure is illuminate the measurement area with a light seed optics. The third one, calibration. Calibration means define the pixel size in the real world. The first, take an image with a PIV camera on the measurement plane illuminated by the light seed and acquire continuous images. Next one is a vector calculation method. The first, determine the interrogation window. Interrogation window is this one. For calculating the vector into consecutive images. The second, correlate called FFT within the analysis window to calculate the strongest peak in the correlation plane. Explain like this. Since the peak is considered to be the most dominated particle movement amount in the analysis window, it is expressed as a vector in the analysis window. Next one is a calculate the vector. It is desirable that the maximum displacement of the particles between the first and the second image less than 1 divided by 4 of the analysis window size, which means the movement of the particles from the first image to second image, 1 divided by 4 pixel is a amount of a movement. It is good for the PIV analysis. Next one is a calibration. So once the image size is fixed, it is necessary to calculate here. 1 pixel is how many millimeters in reality. So this allows you to know how many pixels the particle has moved from 1 to 2 frames. Equal how many millimeters particles has moved. Also knowing FPS, then you can calculate the velocity. So for the calibration, we need to shoot actual measure, then import into the KoncertII. If you can see from here to here, there is a green line. Then you will calculate, the software automatically calculate 1 pixel size is how many millimeters. So next one is our own developed PIV software called KoncertII. It can be used any type of PIV. Plus, you guys may know the German Aerospace Center called DLR. The KoncertII uses DLR PIV algorithm. This algorithm is a world standard So also Concerto has a lot of functions like here. And here's a key point features. The first of all, DLR's PIV algorithm Concerto has so this is a world standard. System control and real-time PIV analysis, which means very good match with NACS camera. Scatter view, uncertainty calculation software, FD for correlation, and also can be used any type of PIV. This is our own software. So now I'm going to introduce about the online means. The PIV software has an online and also offline version. Here is an online procedure. The right side is offline procedure. So if you choose a KoncertoII online, so procedure is almost like a half compared with offline. The first one, if you take a look at the online procedure, camera control and temporary PIV analysis. So if you use an online Concerto, you can do these things via Concerto. Then data recording to the PC, automatically import to the Concerto. Then you just need to do the PIV analysis. Versus offline procedures, you have to do test shooting with M-Link, record data onto the PC, import to the Concerto, and then you need to check the shooted data is suitable for the PIV analysis. Then if you think shooted data is not good for the PIV analysis, you have to go back to the first. But if you use an online procedure, this procedure can be skipped. And here is another point. The other PIV softwares cannot online control NAC cameras. So this is a good sales point. So here is how to choose a Concerto. KoncertoII has a DLL PIV algorithm. And also, the customer doesn't have a much budget. We also have the Seika Digital Image, our company's original PIV algorithm. Both of them have an online and offline, but the DLL PIV algorithm can be updated to the 2D3C, means stereo. So Seika Dia original PIV algorithm, this is little reasonable. And also has several options like this. The next one is a measurement result. By using a PIV software, instantaneous value, and also average, RMS, and the velocity. And of course, you can make a movie. Okay, next one is a function, optional function of the Concerto. Now, when I started to talk about today's seminar, I sometimes introduce about the PTV. PTV means a particle tracking velocimetry. This is not same as a PIV, particle tracking velocimetry. So PTV is a method of the measurement full velocity by injecting the large number of the particles. So compared with a PDB, PDB follows individual particles versus PIV, which we studied about today. PIV follows the numbers of the particle. This is most different. But the PDB is also one of the optional function of the Concerto. So next optional function is called FD4. FD4 correlation is an algorithm developed for time series PIV. It is possible to analyze temporal velocity fluctuations and the turbulence in each analysis window of PIV. The next one Next one called POD. It is possible to extract typical flow structures from the velocity vector data of the flow field obtained by PIV. So Concert has also this kind of optional function. So it depends on the customer's needs. One more function, optional function. Here's a data authenticity evaluation tool. So based on the data obtained by the PIV analysis, it generates various evaluation data like this. So this optional function displays the correlation coefficient, displays SH and ratio pixel movement amount. In each value display the particle movement speed. So blah 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 blah. So if you use this function, you will able to see your analysis data is reasonable or not. So let's go back to the type of PIV. So here is a 2D2C called 2D PIV, use one camera, versus 2D3C, use two cameras. Okay, this one is also like a 2D PIV. So if you use a stereo by two cameras, you will make like this kind of slide. So you will understand the flow X, Y, and Z. So next one is a micro PIV. If you use a microscope like this, you will able to see visualize micro scale. And this one is a little different compared with normal micro PIV. It's called confocal micro PIV. Confocal means like a scanning. This is kind of interesting, so I'll explain about it. Confocal micro PIV is a system that uses a confocal scanner in addition to the optical system of the normal microscope. So this one uses a special items. A normal micro PIV means left side one. The causes error because the information in the depth direction is also mixed. But this one, confocal scanner, it is possible to cut off the light emission before and after the focal plane. So that means same as a PIV idea. If you don't use a confocal system, in the micro space, you will see the depth as well. But if you use a confocal micro PIV, you can slice the visual. You can slice the image. Okay, this is a video. So actually this one is a very, very, very tiny price. But we can do the visualizing like this. So if you use a confocal scanning image, it's like a basic idea is the same as a PIV using the light seed. So scanning the one slide, then you will see the movie is like this. So if you see like size, it's very, very small. So I said the confocal micro PIV is a sliced movie. So if you have like a layer, you can mix the movie like this. And with the PIV analysis, you will also see the vector informations. So next one, when inquiry comes from the potential customer, please ask these questions below. The first application, of course, they want to measure airflow, water flow. This is very important. what flow they want to. Okay. Okay, and next one is the availability of the optical access. Sometimes the customer says, this is a water flow, but you cannot see by camera. Of course, the flow cannot see by camera, means like there is no optical access. We also cannot able to do the PIV analysis. So possibility of the seeding. So as you guys already know, for the PIV measurement, camera, laser light seed, and also seeding. These 3 points are very important. And next one, please ask this, the expected flow velocity. If the customer or potential customer is interested into the PIV analysis, they may already know the rough velocity. So this is also very important to choose a camera. And the measurement size. Measurement size means like a field of view. Then we will choose a camera, and it depends on the sensor size. We will choose a lens, then calculation of the working distance. So if you have the customer's inquiry, you have to ask about the velocity and also measurement size. Seeding is possible or not. Okay. Okay, next one. Situations where PIV may not be able to use. So I will send out these documents, this PDF later to you guys, so you guys can take a look later. So if you have a potential customer or inquiry, we will help you to system up. So please don't hesitate to contact us. My name is Kota Nagatomi, so here, and Jun Machi, he also gave the presentation. Unfortunately, Chao Ma, he's a Chinese sales guy based in Japan, but unfortunately he cannot join today's seminar. But so we also have the Chinese guy. So if you guys have any questions or inquiry, you can also use the Chinese. Here's our company website. Of course, we have an English site and also Chinese site. And if you go to the YouTube channel, there are several PIV or particle image analysis data movies you can see. Finally, location, the Seika Digital Seika Digital Image. We are located in Tokyo, Akasaka, Minatoku, which is very close to the NAC. If you take a car, just like 10 minutes. So if you guys have a chance to come to NAC, you can also come to my office. Thank you very much.
Okay, thank you very much for the detailed the presentation about the PIV, Nagatomi-san and Co. It's good to hear the presentation, and then this time I think you understand about the 2D PIV. This time basically focusing to the 2D PIV with continuous LED or the continuous laser. And then I think you understand the KoncertoII now control the NAC camera like Ajax camera, Q camera, and then also like ACS coming soon. So it will be useful for you to promote to your customers. And then also I think the last during the course presentation in the video, you saw how the KoncertoII software real-time control, online control the camera, and then show the vector in real time. That is also very useful, I think. And then from the Nagatomi-san's presentation, you understand how to select the camera and then decide the shooting parameter, select the lighting, shading. These are the important to make a system. And then but it is, I think, needs some experience and know-how more. And then this time we will share the presentation data later, so you can also learn from the Nagatomi-san's presentation more about the PIV. Okay, so let's go back to the presentation. Okay, so let me just give you the today's seminar's summary. And then for today's, our main topic is about fluidics application. And then during the course presentation, he explained about the fluid measurement. It's quite wide, like inkjet, spray, or there are various applications there. And then just looking back our project, like roughly more than the 25%, something relates to the fluidics. So it's these application is quite important for the high-speed camera business. And then the customer's demands not only capture the image by the high-speed camera, but also requires like a particle diameter measurement or the PIV, density measurement, pressure measurement, or the temperature measurement, and so on. And then this time, thanks to the Seika Digital Image, we could explain about the particle diameter measurement based on the Dia Image software. And then also about the PIV with the KoncertoII software. So these software or the system will be a good tool for you to give the customer the more, not only the hardware, but the system to introduce the customer the system. So please use this opportunity to expand your business for the especially in the fluidics measurement. Okay, thank you everyone. So is there anything you want to talk?
Hey, by the way, thank you very much for participating in today's seminar. Dia Image and also KoncertoII. These softwares are very, very good for best match with the next high-speed camera. Thank you very much.
Okay, so thank you very much again. So see you next at the next training in the future. We will announce to you. Okay, so bye.
Bye-bye.